This is lead code number 2787, ways to express an integer as a sum of powers. Given two positive integers n and x and nx, return the number of ways n can be expressed as the sum of xth power of unique positive integers. In other words, the number of sets of unique integers, this n1 n2 up to nk, where n equals to n1 power x plus n2 power x plus up to so on nk power x. Since the result is high, we use modulo. For example, n equals to 160 and x equal to 3. One way to express this is 2 raised to the power 3 plus 3 raised to the power 3 plus 5 raised to the power 3. So this question, what we have in this question is that it is saying that we have n, we have x. So that n, it can be anything below 300. N is less than equal to 300 and x is less than equal to 5. So here what we have is that we need to find a set, a unique set. Set is already unique, so a set we have to find such that it contains the integers whose power to x, whose power to so suppose this is 1 2 3 4 5. So any element 3, suppose, to power x plus 2 to the power x plus up to so on 1 to the power x plus 4 to the power x plus 5 to the power x, it should be equal to our n. So how many such sets can be possible? So the number of elements can be anything from 1 to anything. Of course, the maximum we need to find. So what can be the maximum number of elements that can be there? So if we go for a basic approach, like 1 plus 2 plus 3 up to so on up to n, and the maximum we can get is 600 from here. So n plus 1 by 2 equals to 600, n square plus n minus 600 equals to 0. So the value of n here would be 24. So at max we can have 24 such numbers. So for finding 24 such numbers, the first thing comes to my mind is to have them randomly. Like first I will take x, first I will take 1, then I will take 2, 3, so on up to n. So at every time I will see that should I take it, should I not take it, should I take it, should I not take it, up to so on, and I do the sum. And if I hit the sum, I will do answer plus plus. If I don't hit the sum or it overshoots, I will return. So if I follow this approach, it would be giving me a TLE for sure, because it will go to n, like for worst case it will go for 300 C24, which is approximately equals to 10 raised to the power 18. So it is a very large value. So here what we can do, what I thought of is the 2D DP, which we can process here. So the idea is that we need to have a DP of n plus 2 and n plus 1 such that if we are at index I from 1 up to so on up to n, if we are at index I, the DP of I j tells us that if we are at index I, the ith number is there, ith index I number is there. So if we are at ith number, so this j, this tells us that if we are at ith number and we want to get a sum of, if we want to get a sum j, so in how many ways we can get it? That's what it says. So how we can use it? So there are two ways which we can do here. So at DP of ij, in this final set, I can do two things. Either I take I take it or I won't take it. So if I won't take it, so what should be the dp of I and j value? It should ask the next one, dp of I plus 1 and j, that whatever your value is, give it to me as it is, because I am not taking it from my own. Okay, so the next number will give him the sum required, which is j. But if we take the ith number, now what we have to do, since it is not the ith number itself, it is I raised to the power x. So what we need to do is we need to have dp of I and j minus I raised to the power x, and the value of j should vary from n to I. Sorry, because if we want a sum of less than I, it's irrational to find it, because you are at index I, you want a sum less than I, you want a j which is less than I, which is not possible. You are standing at index I and you are asking, give me a number less than I. How can it give you? It cannot. Other than 0, it cannot. So these two things we need to do. So dp of j minus I of x, we need to find this. So it would be, sorry, it won't be like this. So dp of ij, it would be dp of I plus 1, and now we deduct j minus I raised to the power x, because we give the value ij now plus equals to, so we will add to ij by deducting this sum. We are taking I and we are saying to the next number that we have already deducted I raised to the power x. Now give me the sum. How many ways we can get this sum? So the next number will give you this thing. So what we can have here is that first we will see if j minus I raised to the power x, is it greater than or equals to 0? Because if it is greater than or equals to 0, then only we can take it. Otherwise it's irrational to take it. So the first condition is this. Okay. So if this is true, we will do this, and in the next line what we will do, that dp of I and j equals to dp of I plus 1 j plus dp of ij whole modulo m, because we also are trying to find a way in which we are not taking the current index, we are not taking the current number. So what we will do, we will just add to dpij dp I plus 1 j, so it will give us the number of ways in which we can find j if we are not taking the current number. So first we will do this, then we will do this, so we will be getting our answer like this. Now where would be our actual answer that would be lying? That would be lying in dp. So what we need to find? We need to find that in how many ways we can get a sum 300. Not 300, we can get n. And we're starting from where? We are starting from 1. From 1, in how many ways we can get it? So that would be our answer. Because at 1 either we take it, either we don't take it. So in that way we will get our answer. So dp of 1 and n will return the answer which we need. One more thing we need to do is that we need to make sure that dp of I and 0 is always 1, because we want a sum 0 from any index, it will always be 1. So we will set every value such that sum when required 0 equals to 1. So here is the solution for that. Here is a power function which I'm not using math.pow, so I have created a power function which is not a overhead, unlike using the math library. So first we will take mod 10 to the power 9 plus 7. I have also took a threshold here which will a little bit reduce our efforts, not much but little bit reduce our efforts. We have took dp n plus 2 into n plus 1, and we are putting all the 0 sums to be 1. Now threshold is something like, if we have power 1 we can go till 300, we have power 2, the maximum number we can go till is 17, because 17 square is less than 300 and 18 square is greater than 300. That's how it is. So we have this condition j minus t is greater than equals to 0, and dp of I plus 1 and j minus t is not equals to 0, because if it is equals to 0, how does it matter? It will obviously be 0. If we take it or we don't take it, this does not make any difference. Let's just remove this. It won't make any difference. So next we will be doing is that dp of ij plus dp of I plus 1 j and mod m. So that would be our answer. Let's run this. I think some network issue. Submit it. So it has been accepted. So the main thing in this question is to find a unique way to get the thing done. So since we were having a TLE for having arbitrary number of selections, so we need to devise a method where we can find that in how many ways we can get this, because every time, since n is small, what I thought of, since the n is small, we can devise a way that we can find this thing, because at the end of the day, end of the question, the sum will be less than 300, and if the sum is less than 300, we can devise a way that we can make the answer for less time complexity. So thank you.